Hi, this is lesson 2.1, day 1. We have the section 2.1 is quadratic functions and models. For this first day's lesson, we need to be reminded just the quadratic function in general, just in as far as a function, f of x equals ax squared plus bx plus c, that I have written here. Remember, the graph of a quadratic function is a U-shaped curve called the parabola. We will be graphing those without a graphing calculator. We know that certain things about transformations of the parent function. Recall that just in general, y equals x squared, the parent parabola. And if I always forget that, or if I forget any part of that, I could always make a table of values. And I usually pick a couple of negatives, 0, and a couple of positives. Negative 2 is x, would be negative 2 squared. There's the bell. And that is a positive 4. Negative 1 squared is a 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So what we get are these values that generate our parent parabola that you know so much about. Now, different transformations occur and can shift left and right, up and down, flip over the x-axis, stretch it vertically or compress it vertically, or certainly with stretch and compressions horizontally or reflections over the y-axis. Those are not easily seen or shown from an equation, or from the equation you can, but visually you can't notice it as much from the graph or on those other ones, the horizontal shifts and reflections. So the first ones in your classwork are just going to be some matching ones, and that is 1 through 8, and you're going to do 1 through 8 all. But for instance, number 5, it says f of x equals 4 minus the quantity x minus 2 squared. So just in talking about what kind of transformation occurs from the parent graph, we notice inside the parentheses with the x that it says x minus 2 quantity squared. I know the squared part means it's the parent parabola that we will be transforming. This minus 2 inside with the x indicates it's going to shift to the right 2. And I like to go ahead and make those notes. Shift right 2. The negative just in front of it is going to indicate the reflection over the x-axis. As you know, when we have the negative in front of the function like that, reflection over the x-axis. And visually, you know that's going to open down the parabola. And then the 4, also, if you notice, you could move it to the back and put it as a plus 4, so maybe what you're used to seeing, but it could be in front or behind it. And so that is positive, so that would indicate a shift up 4. So if I look at the matching, I can see that I'm looking for the vertex shifted to the right 2 and up 4, which from the parent parabola would be 2, 4 as the parabola vertex, and I know that reflection over the x-axis indicates it would be opening down. So in looking at that, I see that the graph of f is the correct one. The other section besides this matching is going to ask us to sketch the graph without the graphing calculator, and then also identify the vertex and the axis of symmetry and the X-intercepts. Let's recall that X-intercepts are the points where the graph would cross the x-axis. Another thing we call X-intercepts are solutions, because that would indicate for solving the quadratic equation, it's set equal to 0, like we have been doing in A.5, that we will get the solutions, and then X-intercepts just list them out as coordinates. But the solutions, we know roots also are the x values that we get from the solutions, or the actual x values on the x-intercepts. We also call them zeros. Just those are always terms that you need to know, and know that finding them is the same process. So just a little notes there to remind you on that. We're going to look at number 17 from the tomorrow's classwork together and work through it. In looking at the equation initially, I noticed that I know the parent parabola was x squared. The plus 5 inside the parentheses would indicate that it would shift to the left 5. I just like to make the note. The minus 6 at the back would indicate that it shifts down 6. There's not a negative in front of the squared term there, so that would indicate that it's not a reflection to open it down, a reflection over the x-axis. So this one just would be the parent parabola just shifted to the left 5 and down 6. So in doing so, I'm going to graph my vertex at -5, -6. And that was one of the things they asked for, is to locate the vertex, or write it down. And then from there, if I pretend that's my new 0, 0 point, it's still going to open up. It's not a vertical stretch or compression to change that counting pattern. So we still will have our values from pretending that's 0, 0. We have 1, 1 and 2, 4. Whoops. And we draw our parabola. The next point you may want to find, because 3 squared is 9, so if I went over from the 0, 0, which is my new vertex, and then up 9, just to kind of get another couple of points to see where my parabola is going, because the next thing is to find the x-intercepts, which is just to solve it, which is what we've been doing in the other section. Before I do the solving, I'm going to talk about the axis of symmetry. Of course, this is symmetrical over a vertical line, and the vertical line would be crossing the vertex, so it's going to match the x value of your vertex, and the axis of symmetry is a vertical line, so it's always going to be an x equals there, and it's just x equals -5. So it's going to match the x value of your vertex. To find the zeros, or the x-intercepts, we are going to set f of x equal to 0, and then we're just solving the quadratic. So in doing so, I see I have it in the format where x plus 5 quantity squared, so I'd want to isolate the squared thing, which means I'd add 6 over. And in doing so, I'm going to actually switch sides. I'm going to go ahead and say x plus 5 quantity squared equals 6. If that's okay, I'm just switching them. And now I've isolated my squared term, so the next step would be to square root both sides, which I know I just get the x plus 5 out. The square root of 6 does not simplify, but don't forget it's plus or minus. And last I will subtract 5, and I get 5 equals, I'm sorry, excuse me, -5 plus or minus, making some stray marks here, plus or minus the square root of 6. Remember, that is two solutions, x -5 plus the square root of 6 and -5 minus the square root of 6. So when they ask for the x-intercepts, which I will write back up here, I know that the x-intercepts are always when y equals 0, so these are coordinates when we list them as x-intercepts, and this is a -5 plus the square root of 6, comma 0, and a -5 minus the square root of 6, comma 0. Those are two coordinates, and if you notice on the graph, just our sketch anyway, but it's not crossing at an integer point on the x-axis. But these are the actual x-intercepts, and these are the parts that they're asking us to do for this last section on the classwork. That is all.